Welcome everyone to integrating Neo4j with Google Gemini. We have Jitendra Gupta who will be presenting today, and we'll hand it off to him.
Thanks, Ella. Let me take it to my screen. Okay. Please confirm if you can see my screen. Yeah, thank you. All right. So I'll get started. My topic is going to be integrating Neo4j with Google Gemini. Specifically, uh, so we are going to discuss about the architecture patterns on how the agents are making sense when you are integrating it with the Neo4j, or I would be precise, Neo4j graphs. Okay. So quickly jumping into the session's agenda and the flow of this particular session. So here we are going to discuss like why graphs and the generative AI makes sense here in more into the contextual intelligence. So we'll be walking through on the patterns about how the graphs and the AI models, basically here we are talking about the Gemini model, uh, work together and improve the overall in the improvements on the GenAI agents, right? So we'll look into the quick introduction and the context setting. We'll look into the foundations of graphs and Gemini. Then we'll walk through into the core architectural patterns, the various patterns that really make sense in altogether in the AI agent journey. Then further we'll walk through into the implementation and the best practices. And at the last part of it, somewhere we are going to have a quick demo walkthrough. It's not a live demo, but over the presentation will give a understanding of how that looks like. We'll end the session with the challenges and the future roadmap. And yeah, with that, let's get started. So here let's first understand what is a graph, or I would say what is a property in a graph, right? So when we are looking it from the graph perspective, basically we'll have nodes. Nodes will have their properties. Then there will be relations, which is nothing but s, and the nodes in that you will have the edges and the relationships in between, and there are going to be their properties, which really makes the whole graph scenario here. So if you see here, each of the node here represents as an entity, like one of the entity in a given table, if you extrapolate those relationships, and they will have their properties as such. Now, how the properties connect to one node from another one is where it really makes the sense altogether. Now, when we are combining all of these properties of any graph and use that building our own, you can say the Cypher queries, it really supports it very well. Now, before we move forward, let's have a quick comparison between the vector DBs and the knowledge graphs. So when we are discussing about the vector DBs and knowledge graphs, we basically vector DBs are something that we use mostly with any of the AI models in previous scenario. So when we want to perform, let's say the similarity search, that's where vector DB supports well, right? But if we want to extend that capability further, that's where we will probably go for these knowledge graphs, which really talks about all explicitly gives us the inputs on what sort of relations, and also builds on top of that the context. Then talking about the data models, so if we take the example of vector DBs, they are really very dense vectors, high dimensional vectors. In case of knowledge graphs, they are going to be nodes and edges with their properties. Taking an example of some of the use cases with the vector DB and the knowledge graphs. So in case of vector DBs, we can see the uses where we have the RAG search, the ranking, all those. But with the knowledge graphs, we get the regional capabilities enhanced or added, the recommendations or identifying the graphs, all those capabilities could be looked for the knowledge graphs. But the very important aspect here is that the explainability component here. So when we work through the vector DVs, it do explain the components well, but they are low because of the distances that is added to any of those vector dimensions. Comparing it with the knowledge graphs, they are very highly explicit relationships for one entity to another one, and that really helps in overall, you can say, agentic AI or AI approaches. So here, if you see, graph provides a context and reasoning which is beyond the similarity search. Okay. Now let's look into the graph RAG and LLM synergy here. So here we are looking at combining the knowledge graphs with the RAG itself, the retrieval augmented generation, which overall enriches the prompt that we write, and it also reduces the hallucinations altogether. The graph, which structures the or anchors our overall prompting, and at the end also provides the memory context before we invoke the generative AI models, right? Just take this particular example here. So let's say that we want to walk through a agentic loop here. So what a agent does in general, right? So if we see the steps that is performed by an agent, so basically it understand the context. So basically it perceives the context that is the user is being looking or asking for. Based on that, it plans execution, and also it acts upon it. After the execution, not only it just completes the task, but it also learns for the further context building or a long-term or short-term memory context as well. Now, there are challenges with any of these AI models or Gen AI models that we use, the memory crisis. So context windows are very finite in those situations. So LLMs basically they forgot very important informations, and these agents need to be structured to persist their memory for longer context building, and for which these graph or I would say knowledge graphs makes the sense here. So with these knowledge graphs, there are additional capabilities, which is nothing but the TKGs, which is temporal knowledge graphs. What they do is they record all of the events with the timestamp added to it, and they also have the decay policies, like if some of the context is no longer needed, they are discarded. Okay. So altogether, this enables agents to recall the past instructions and also reason it out over the time whether you need those memories any further or not, and if not, then discard it. Okay, now let's jump into the various patterns or architectural patterns that we see when we are trying to combine the graphs with the AI models or Gemini in this scenario. So let's say that we want to translate questions into Cypher queries. So what it takes, an LLM parses the schema and also the domains it belongs to. And at the end, it gives us a Cypher query which is directly ingested into the Neo4j. So here in this flow, we have a user which goes and interact with the Gemini model. The Gemini model behind the scene is going to convert that context into the Cypher query, and then Cypher is going to be calling out the Neo4j databases to retrieve the information. Now those responses are again fed back to the Gemini, and Gemini is providing those responses to the user back. Now there can be challenges around it, like if we are not able to provide the right context, if we are not providing the enough information to these uh, Gemini models, it may misinterpret or misunderstand the query, and so the Cypher queries will also be distorted. So we have to ensuring that should be certain guardrails around it, like providing schema to the model. Also give a retry capabilities or added to your code or application that you are building around it. And there should be a verification, or I would say the test cases being already performed, so ensuring that there are no errors whenever it is interacting with those Neo4j graphs. Okay, so as I have discussed, like the benefits and the challenges here. So if we see the expressiveness here, the benefits what we are getting over utilizing the graph plus the Gemini models, it gives you rich queries and analytics capabilities. But also on the downside, if you see, it requires us the hints on the schema, and as much quality of schema that you provide, the quality improves, but which gets very difficult in real time scenario. Also the quality depends on the prompt and the LLM. If we talk from the latency perspective, the queries are performed faster once the query is generated, but the LLM interface adds really additional overhead here. Looking it from the reliability perspective, so deterministic query execution is performed, which is on the benefit side, but LLMs also can hallucinate, where we really need to put those guardrails which we discussed in the last slide. Now let's look into the another pattern. So in this scenario, we are looking at graph as a long-term memory. So let's say that we want to persist our agent interactions and context in the Neo4j databases. So for after each of the actions, whatever the agents writes, that is being saved into the graphs, and also the subsequent request to the request or the query to the graph is recalled prior to knowledge graph and maintaining the continuity here. So in this scenario, as we were lagging behind on the number of in context that we can save, the size of context that we can save on the Gemini, now that is being improvised by integrating it with Neo4j graph databases. So here we are able to write the observations, decisions, and outcomes as the nodes and relationship with the timestamp. And also we can very handy read out all of those information with the facts and the context by using the Cypher commands. Okay. Now here what is happening? So there are two scenarios. One is episodic and another one is semantic memory. So in the episodic memory, what happens is we are recording the sequence of events with timestamp, and it forms a storyline for interaction with the and including the actions itself. The applications could be replaying the scenarios, tracing the decisions. So all of that can be done when we are uh, performing the episodic memory in this scenario. The other approach could be for semantic memory, where we store the facts and relationships about the domain, entities, attributes, and the connections. And its applications would be more on the reasoning and the recommendation side. Or if you want to expand our query because it already had the context about it from the past that we have already saved. Okay. Now, the third pattern, which is a hybrid approach, the hybrid reasoning approach. Here we are combining graph traversal with the LLM reasoning itself. So we use the graphs like to compute all set of candidate results. So we basically try to rank them together, and then we go and let the model reason out over them and explain the outcomes, right? Now with this, we are able to get into more closer to our better results and improved outputs here. Like one of the example could be determining the churn risk. So we compute the centrality and the community, and then we summarize the key drivers with the Gemini, right? So this really improvises my overall outcomes that I can expect for scenarios like determining the churn risk. The fourth pattern is multi-agent coordination. So as we are moving forward, we see that the dimensionality is increasing. Here we are talking about the multi-agent coordination, where the multi-age or multiple specialized agents, they cooperate over a shared graph. So in this pattern, what we are seeing is, let's say that we have agent 1, and it has added some knowledge to the graph. So it writes to the graph and reads from it. Now there is another agent which also is dependent on the same context. So here the agent 2 goes to the shared graph. It probably reads first of all the information, and based on the further inputs it writes back to it. So now the same graph is being shared by multiple agents, and that really helps all together in the better coordination of the multi-agent scenario itself. A quick comparison on all of these three patterns that we discussed, the four patterns we discussed, right? So the very first pattern is about the natural language to Cypher conversion. The other one is for the graph memory, then hybrid reasoning and the multi-agent. Now what we are seeing here is that if we are starting as a very beginner on this approach, the approach should be that we start with natural language to Cypher query, where we have the medium latency, less complexity, but there is a high explainability to it. Looking at the graph memory approach, where the latency is going to be high because first of all it has to store those memories, create the indexing, then retrieve the information. All that adds a lot of latency. However, the complexity can be reduced. Again, it also provides us a high explainability because it has a lot of context to work with and then provide the information back. Then comes the hybrid reasoning, where the latency is low but the complexity is high. And again, if we look it from the explanatory perspective, it is quite medium. And at the very end, once we are really apt with our approach, then we opt for the multi-agent pattern, where the latency can be medium to high, complexity is really high, and the explainability as well is again very high because of the multiple agents are working with the shared context which is saved in the graph. Okay, a quick look into the decision flow here, what pattern to select. Let's say that as we start, so we need any data persistent. If that is yes, then we go for the graph memory, or else the natural language to Cypher query can be used. Now further to that, if we need any analytics or not. If we need analytics, we can go for the hybrid reasoning model, and if not, then multi-agent scenario can be used where a shared context is being applied for multiple agents. Okay. Now, what are going to be the security and IAM best practices here? So while we are working on any of these approaches, we need to have the least privilege and the zero trust enabled or for any of these communications that we established, which could be like providing the minimal permissions to the agents by enabling the MFS, and also at some of the scenarios it can be a just-in-time process as well, access as well. Certainly, there should be a practice of following the uh, RBAC and the ABAC in the Neo4j, like not only Neo4j but also for the cloud. So, which helps you separate the duties and restrict any of the administrative accesses. The credentials has to be saved into a secret manager. Basically, we are looking it from the perspective that when these graphs are or graph databases are s- being deployed to the cloud, we can use those secret manager services on the cloud for maintaining the secrets. Also, always enable, so it's always a best practice that we enable this monitoring and logging. So there should be a centralized logging and monitoring enabled for all of these applications aspect or most of the components that we work with, right? Now jumping to the cloud architecture here, so far we discussed what is the pattern or the integration between the graph and the Gemini models. Now let's take it further to the cloud architecture. So on the cloud, there are basically going to be on very high level this particular services like Vertex AI, Cloud Run, or AuraDB. Now if we look at the flow, so let's say that a user requests certain queries to an agent which is basically deployed to the Cloud Run already. Behind the scene, Cloud Run is going to interact with Vertex AI, and Vertex AI is going to work with Neo4j by passing on those Cypher queries, and it gets back to the result. Okay. While you work on uh, creating your own application around this architecture pattern, so I just come up with these four folder structures that you can follow. Like let's say that you have the agents folder where the orchestrations, memory, and the connections are created for the agents. There can be another folder where you can have the graph schema and queries, and then you have the prompts, which is going to maintain those templates and instructions, the system instructions and the user instruction as well, which can be maintained within the prompts folder. And for the UI perspective, you can either have a Streamlit application or maybe even better UI frameworks that can be used for deployments. This is a very uh, basic structure that we follow for any of these application creation. Now, while we work on this, we should also consider the configuration management and caching. So we want to create those configurations like storing the environment variables, secrets into the config file. Then while we create this application, we also should be enabling this caching approach. So we should be caching all those LLM responses, graph queries, and which reduces the overall latency and the cost as well. The implementation of retries, exponential backoffs should be implemented, which ensures the idempotent retries or writes, and it avoids the overall data duplicacy when we interact with these models. As I have already discussed that we should have monitoring and logging enabled here for observability, and also dashboards and alerts are created, which helps you in monitoring these models well, and audit and logging has to be enabled. From the scalability point of view, we should enable the horizontal scaling, auto scaling, resilience, and the circuit breakers. For the from the infrastructure perspective, you see, let's say that when you have your agents deployed, so for that aspect, you should have all these scalability and reliability aspects covered for the infra part. Okay, taking a quick look at the demo aspect. So whenever we work on any of these applications, so in the previous slide we covered, so we should have our config files, then the Gemini and Cypher and then Neo4j interact together. Then you go for the streamlit visualizations, and at the end you will have the tracing the reasoning and the memory for this uh, application, like the components could be. So very first step here, config.yaml. So what all it should contain at bare minimum. So you should have the Neo4j configurations where you will provide the URIs, user, passwords. Similarly, interaction with the Gemini models, which requires the model name, the API keys to interact with on the Vertex AI platform. And also to enable the caching, we should have that configuration added as well. Next, once you have deployed these to the environment, next is like let's say that a user asks for the queries and the Gemini generates the Cypher commands, and those Cypher commands are passed on to the new 4G as a new session, and the answers are reverted back to the Gemini. This is very pseudo code. It's not the real code that I'm showcasing, but yeah, that's how the flow looks like. Once you have the results back, you can present it back to the Streamlit application as part of the visualizations, and also you can perform the analysis and the tracing and reasoning on um, the alerting dashboarding what we have. So here in as a part of reasoning and memory, here let's say that a question is about from the Alice, that what Alice asked for the tickets, then query is executed, results are summarized, and the next question is being asked. The challenges, if we look at, so the very first challenge is that the latency. So LLM interface and the graph traversal can be slow depending on how we have handled the cachings, if we have pre-computed the indexes or not, and if there are any parallelization we have done or not. So based on those scenarios, we should be able to tackle the latency. There can be schema drift, like changes in the graph schema breaks the queries. So what we can do is we can version our schema and generate the queries via the introspection. Hallucinations can be another aspect to look at. So hallucinations may, I mean, LLMs may hallucinate with the incorrect ciphers. So we can add the validations and fallback for heuristics for that. The next component is for the scaling, where heavy workloads require the scaling databases. Okay, and we can use the auto scaling and monitoring here. Okay, so what could be the future roadmap here? The future roadmap could be like so graph rack, which enhances the graph rack enhancement, which can be like integrating regional search and semantics, which overall improves the schema discovery and query reliability. Gemini API agents, which can leverage this agentic API to orchestrate task, memory, and tool uses. And we can have the graph and vector fusion, where we fuse the vector stores and graphs for hybrid retrieval, unifying the embeddings and relationships. Quick recap and takeaways. So ground your agents with the graph memory to provide the better context and the history or longer history. Leverage the Gemini for multimodal reasoning and the cipher generation itself. Approach for the hybrid reasoning combines the analytics with the language understanding itself, and coordinate multiple agents through a shared knowledge graph, which enhances the overall agent to agent communication in this scenario. With that, I end my presentation. You can connect with me over LinkedIn or other platforms. Here are my credentials. Thank you so much.